In Algebra 2, Section 7.4, we're dealing with nth root. What that means is, so far you guys have dealt with a lot of square roots, but now we're going to deal with roots that are bigger than squares, anything bigger than squares. What I mean is this index right here used to represent a 2. And remember how we're taking out pairs in order to do square roots, but now this number can be anything. That's hence the term nth root. This can be 5, 6, whatever it may be. And then we have a number and a radicand. Okay? So let's review a little bit. Okay? We were dealing with, if there is no number there, I'm going to always assume that if there's no number, I'm talking about square root. Okay? Because on square roots, there's no number on the outside because you assume that, again, it's squared. So let's start with square, something that you're familiar with. And remember what squared means is that I'm going to separate this. So I'm going to take 16 and I'm going to go 4 times 4, 2 times 2, and 2 times 2. So I have 4 2's, 1, 2, 3, 4, and I have 8 x's. Oh, this is going to be long. Let me do this. 1, 2, 3, 4 times 8 x's. Okay? Now, and once you get this, you can start putting in pairs, but this number tells me how many sets allow me to come outside of the square root. So it says 2, so that means every 2 represents 1 on the outside. So every 2 inside the radical, okay, every 2 sets becomes 1 on the outside. So if I have a 2 out here, that represents 1, 2 on the outside. Another 2, another set represents another 2. Here's 2 more. Here's 2. Here's 2. Here's 2. If there is anything left over and there's no set, then they're left in the radical. But in this case, there's nothing else left over. I've circled everything, so then I just multiply everything out. This is 2 times 2 is 4. X times x times x times x is x to the 4th. So again, this on the outside tells me how much I can take. Okay? With parentheses, it works the same way, but I'm just going to keep the parentheses. And it tells me I'm going to do q third plus 5. Now this is a lot of work. Most of you guys can do this in your head. I understand that. But it's just, I want you to see it visually so that when you apply it, it'll come, when you apply it to more difficult ones, you can write it out and it'll help you. So yes, I understand that you can tell. But again, there's nothing out here, so I'm going to assume that it's 2. So I'm looking again for pairs. So here's 1 pair. So that means on the outside it represents 1. And here's another 1. And there's nothing else left over. I've underlined or circled everything. And so my answer, if I multiply them together, okay? So this one is a little bit more tricky. I'm going to take 243 and I'm going to try to factor them. Okay, let's try 243 divided by 9, 27. So I just chose a number and divide it, see if it's divisible. If not, I keep going to try to find, just to make it lower so that I can multiply. And here's 3. 27 is the same thing as 9 times 3, and this is 3 times 3. So once I have that number, and I'm going to put it here, I'm going to take the last number on each tree. So 3 times 3 times 3 times 3. Okay? Now without writing all this out, I can literally take this number and divide it by this number. And if I get any remainders, I leave it in. Okay? So that means I have 10 A's. So I have 2 sets of A's of 5. I just want to see how many A's of 5. So if this was 11, I would have A to the power of 5 times A to the power of 5 times A, because it's a leftover. And this one I have B to the 15, right? Which would be B to the 5. I ran out of room, but it's B to the 5 times B to the 5 times B to the 5. And if it was B to the 17, then I have B to the 5 b to the 5, b to the 5, and then a leftover b squared, which would be left in the radical. So in this case, I have permission to take out sets of 5. So here's one set of 5. So all these 3 5s in here, okay, represent 1 3 on the outside, because that's what gives me permission. That's the ratio exchange. So this I have a to the 5, 1 to the 5 gives me permission to take out 1a, gives me another. 15 divided by 5 is 3, you know, so I have b times b times b. So this would be 3a squared b to the third. Right? In this case right here, I'm dealing with -4, and this is squared. So I'm looking for pairs. Now the problem with this is that I have -2 times -2, which would give me a +4. So I can't do that. If I do 2 times -2, it would give me a 4, but then I don't have a set. Right? So there's no way I can go over here, so this is as simplified as it possibly can be. Okay? Because I can't simplify it any longer, because if the only way I can get -4 is if 1 is 2 and 1 is -2. But in that case, I can't bring any of them out. So -4, you just put cannot be simplified. Or just put -4 and just circled it. Okay? But usually just put square root. Doesn't mean that all negatives is just because my permission only gives me 2. Alright? So go ahead and write this down. And then don't forget the vocabulary. And we're going to do like 2 more examples and then we'll be set. Alright, so in this case we have this nasty decimal, right? A hint when you have a decimal like this is I can put it into a fraction. 0.064 is the same thing as 64 over 1,000. All I need to do is count how many places. That's 3 places. So I put 3 zeros and that's 1,000. So it'd be 64 over 1,000. Just check. 64 divided by 1,000 is 0.064. As long as I don't change the value, I can change it into a fraction or into decimal however much I like. So we're going to work with this. And again, it gives me permission to it gives me permission to let out 3 sets of 3. So let's simplify 64, which is 8 times 8. This is 4 times 2, 4 times 2, 2 times 2, 2 times 2. Okay? And then 1,000 would be the same thing as 100 times 10. This would be 10 times 10, 5 times 2, 5 times 2, sorry about Miss Grace, 5 times 2, alright? So I have here 2 on top times 2, and remember the rules, you can always split it. So 64 is on top and 1,000, so 2 times 2 times 2 times 2, there's 5 2's. And this one has 3 2's and 2 5's. Okay? What that means is I can take out sets of 3 from top or bottom. Right? So I have one set of 3, which gives me, I have one set of 3,